Hi. In this video we are going to work on the area and perimeter of segments. Basically, a segment is the part of a circle formed by the chord joining the arms of the angle, or let's say the sector, right? So basically this is called as a segment. Now certainly you can calculate the area and the perimeter of a segment. Now we may end up with formulas, but basically if you think carefully you can figure out the area and perimeter on your own. So let's work on this. Let's say you're given an angle theta and r is for the radius, and we'd like to calculate the perimeter of this segment. Now, for the perimeter we need the arc length, right? And then we also need the length of this side. So let's start with the arc length. So P equals, well, it's going to be theta times r. Remember, we were to go like theta over 2 pi multiplied by the circumference, and then we cancel out the 2 pi's to end up with theta times r as the arc length, right? So this is theta times r, the arc length, plus now I have to go with the cosine rule, right? As I know the radius and the angle between two radii, right, I have to use the cosine rule to calculate this length, alright? So this is how we end up with the perimeter of a segment. Now when it comes to area, we basically calculate the area of sector and then we take away the area of the triangle. So the sector area is all this, right? And then if you take away the triangle area, you end up with the area of the segment. You can see that it takes time to calculate the perimeter and the area, but there is nothing hard. But of course we have to be extremely careful because there is a lot of calculation going on, and even a sign mistake will ruin everything. Now let's see an example. Right, we're going to calculate the area and perimeter of this segment. Now let's start with the perimeter. Now before finding the arc length, I'm going to use cosine rule to find out this side length, right? So this is radius, this is also 5. So I'm going to write down for, well, if we go like this is A, this is the center, this is B. For the length AB, well, the square of it will be 5 squared plus 5 squared minus 2 times 5 times 5 times cosine. Now, the radian measure is given as a decimal, which is totally okay. You just write it here. And if we calculate this, well, I'm going to simplify this further before I use my calculator. This is 25 plus 25, 50, minus 50, because 5 times 5, 25, times 2, 50, cosine 1.2 radians, right? So make sure that you adjust your calculator to radian measure before doing the calculation. So I'm going to end up AB being the square root of this expression. 50 minus 50 cosine 1.2 radians. And this will give me 5.6464 and so on, where I would round this to, well, I'm going to write 4 significant figures to be accurate enough. So it's going to be 5. So if I cut from here, 646 centimeters, That's 4 significant figures. Now to that I'm going to add the arc length. So arc length would be theta multiplied by r, which would be 1.2 radians multiplied by 5. So it's going to be 6 centimeters. So if I add these two, I'm going to get the perimeter of the sector. So I'm going to write perimeter of the segment, right? It's easier to mix these names up. So perimeter of the segment would be 5.646 plus 6, which is 11.646. To 3 significant figures rounding, it's going to be 11.6 centimeters. That is 3 significant figures. So that is the perimeter of the segment. Now when it comes to the area, I have to calculate the area of the sector and the area of the triangle, and then I will just find the difference. So for the area of the sector, I will go like 1.2 radians divided by 2 pi multiplied by pi times 5 squared, right? The pi's will cancel each other out, so I have now, well, that's going to be 25 here multiplied by 1.2, which is 30. 30 divided by 2, it's going to be 15 centimeters squared. So this is the area of the sector. When it comes to the area of the triangle, I am going to go like 1/2 of, well, the arms of the angle is the radii, right? So it's going to be 5 times 5 times. Yes, I'm going to be using that formula with a sine. So I'm going to write sine of 1.2 radians. Now this will give me 11.650 and so on. To 4 significant figures, I'm going to write this approximately as 11.65 centimeters squared. This is 4 significant figures, and then I'm going to take away the area of the triangle from the area of the sector. So basically that's going to be, let me write here, area of the segment will be 15, take away 11.65, so I'm going to have 3.35 centimeters squared to 3 significant figures. Now maybe it would be best if I was to round to 5 significant figures here. As you can see, I ended up with a number which is already 3 significant figures. I didn't need to round it, so it could be a little bit tricky. It could be, it could not be accurate enough for this calculation. So we have to be really careful on rounding in the middle of our calculations, right? But the idea applies the same. The area of segment will be the area of the sector take away the area of the triangle. That's how we find the area of the segment. Now, as I frequently say, it's not about the content in P1, it's about the imagination of the examiners actually, because, well, they could come up with figures like that. 2 semicircles, one cut from the other, or a segment is cut out of a triangle. So they could be asking the area of this, or it could be anything, right? So it is about how you're going to approach to the question, right? And think carefully while working on these. So there is no online self-check in this, just follow the blog to work on the questions in the textbook. Thanks for watching.